So what I would like to talk to you a little bit about today is something I was asked to do in 2010 and 2011. I was getting ready to leave over at the CIA, where I'd worked for a number of years, and the Intelligence Science Board said, could you give us a brief on what's in store for us in the future? And it was some information I think some people didn't know, and I think it's good for people to be aware of what's going on out there. Can you actually send and receive sensory information, like the Matrix? The short answer is yes. What we do know is that DARPA did get permission for 500 operations to do deep brain electrode implants. They haven't published anything yet, but my guess is what you're looking at is human-human thought transference, and certainly in the open science world, that was published last month. Actually, the brain-to-brain transfer of sensory information in 2 humans, and they achieved a success rate of being right 85% of the time. So you can attach one human brain to a device. You can attach the human brain to another human brain. You can direct motor activity, or you can send communication and information. So that's what people are doing. There's a whole world out there of biohacking. I don't know if you're aware of it, but you should be. So normally at the university, we are well regulated by the federal laws about studying and experimenting on humans. There's a biohacking community that is not part of the official science community that is busy trying to attach hardware to humans, and they do it in their basements. They study up on how to do the surgeries, how to connect devices, how to put motherboards in people. And they may use it for some purposes like fishing, using RFID signals in their hands to take information from you. But there are some other interesting developments. When you start thinking about the fluidity of what you can do with the brain, they're experimenting with CE6 and giving people with eye drops night vision. For several hours, a person receiving the night drops can see over 160 feet in the dark. So it's a lot easier to look through your own eyes than it is to put on nods. And it will be a short time before you get a better solution than we get from the biohacking community, but it could also be readily available to almost anybody on the planet. It's going to be harder to keep this under control than it is to keep the special lenses and night vision technology. So I think it's really important that people pay attention to this kind of a thing, because that can give humans the natural ability for a while to see in the dark. So people are playing with chemicals to enhance the human capacity. They're also experimenting now with how do you add a device to the mammalian brain to give it an extra sensory ability. You may not want to detect infrared. You might want to have a room temperature detector of radiation, depending on what your job is in life. So when you think about it, the possibility now is there to develop different kinds of devices. They could be perhaps used either by intelligence people or by people in the military to have an extra ability to be able to see through walls, to see heartbeats. We used to play with the 18 gigahertz microwave detectors where we could pick up heartbeats through anything but solid steel and water, but that could easily be a human who can see the unique heartbeat that's behind the wall over there that's thermal insensitive. So it doesn't have to be IR. It can be a number of things. Anything that you can co-opt is theoretically now possible to adapt to human brain functioning. All you'd have to learn is the code. You'd have to train with it. It might not be natural at first. You might not understand the signal you're getting, but you can add to human brain function. You can also use it to intercept signals. The experiment that was just released this last month, as I said, demonstrated that people could transfer knowledge from one human to another. And I commented to a couple of my colleagues, and I said, I think right now the most direct application of that is going to be either covert communication or running drones. The set of experiments, I didn't have videos to show you, but there have been a series that have shown you can connect the human brain to a rat and control its motor movement and its tail. So you can have non-human animal drones. You can have the human brain probably run a regular drone at this point, but running a non-human drone, something like a cockroach or a rat, would it be awesome. And now if you were watching the Olympics and you see the coordinated maze of drones, the software is now really readily available where you could have hordes of little creatures that can gain access to facilities. or move around in different places, all run by a person sitting in a booth. It's no more technically challenging once you do that than figuring out the logistics of how you're going to send your signal somewhere else in the world and how to protect that signal. But that's now. That's not in the future. So as you begin to think what's in 5 years, the interfaces are going to become more delicate, more refined, and as transcranial magnetic stimulation, it's a rather crude instrument right now. It creates a field that excites just hordes of neurons. But as they refine the technology so you can get a better point specificity to the neurons you actually want to activate, you should be able to do this without penetrating the skull. Either someone could wear a cap, and in fact that's how the latest brain-to-brain communication in humans was done. It was done without surgery and actually signaling via some stimulation to the retina and the brain decoding it. Although the person consciously didn't know what the code was, the brain did. So that I would recommend people becoming aware of that from the human drone technology standpoint. The second field that people may or may not be aware of, I always tell my students, I said I wasn't around when they developed atomic weapons, but Dr. Ventnor's work is, my view, the equivalent of the development of nuclear weapons when you realize that he created life in a cell back in 2010. I don't know if people are familiar with his work, but this technology paired with something called CRISPR, which is like an editing software for genes, makes a number of things immediately available. What he did is he programmed yeast cells to produce anything he wanted. They can produce perfume, they can produce petroleum, they can produce any peptide, anything we program the DNA to do, and it's in the living cell. Right? So in medicine, the goal in medicine now is to be able to do designer medicine and therapy. If we can design a cell to get into your body and release the right product for you, you won't be losing half the drugs you take through your liver when you swallow a pill and it gets digested. These can be inserted into you through the hypospray needles, almost like Dr. McCoy on Star Trek, giving you the hyperspray. It just blasts now plasmids into your squamous cells. But Ventnor was able to do that and has the patent on the technology. But you can engineer anything. You put in a specific gene slicing, you program what you like, you put it in the cell, and it can reproduce and make as much as you like. For those of you who don't know, your DNA is usually all wrapped up in tight little coils. And so what you're doing was when they create plasmids and put them into cells, it sends a signal and tells which portion of the DNA should unwrap, unfold, and produce a product. Now, this is the future of medicine. When you look at this technology in medicine and say, this is going to be done to help people, right? We want to be able to give them medicines. We actually want to correct for genetic deficits. If a kid's born with a genetic anomaly, with the CRISPR technology, the feeling is we can create the portion of the gene they're missing and go have it spliced back in. And that may help a child, either if it's in utero development or once they're older, to have the missing substance actively produced. What would you do with this if you were in security and intelligence? Well, you can do a number of things. You could decide, if you make this gene, we know that certain people in the world who function at very high altitudes very, very well do it because they had a special mutation in their genome that we don't have because we didn't grow up in the Himalayas. But they can function at very high altitudes. Could you give this to people who are going to have to do warfighting in high altitudes and they don't require extra support? Their body makes a much more efficient use and can work under conditions of lower oxygen than the rest of us. You start letting your mind wander. Can it also produce a substance that lets you function longer underwater without oxygen? But these are run by certain mutations in genes, and with CRISPR we have the ability to actually make these and see what happens when we give them to animals, non-human or human animals, that don't have it naturally. You could have the Forrest Gump gene. You guys have been tracking. There's a gene that just makes you stronger. Related to this is an idea called dreads. These are designer receptors that can be remotely controlled. So think about it for a moment. You can create a designer receptor, you can create a cell, you can put it somewhere in the body, and you can remotely activate it when the brain's exposed to the right signal. Using this technology, people have been able to transfer memories from one fruit fly to another by signaling through a light stimulus into the retina. Right now, in most animals, it's done by putting a substance into their body that will actually activate the neuron in the way that you want it. So you have the capacity to create any product. As long as you know the DNA sequence, you can insert it into a living system, and you can remotely control it. So in medicine, we think about how we do that to help people, how we do to repair deficits. Other people are going to think about how do they do it to expand possibilities. Now, one of the challenges that we have is that when you create a cell and you put it in somebody's body, you have to figure out where you want it. What if you want it in their brain? Right? If you want it in their brain and you can't figure out, you don't want to do surgery to plant it in their brain, if I want a product produced in your brain that may affect the way you think, the way you act, one route to that is through stem cells. If you're a quick brush up on your biology, stem cells are cells, they call them God cells. They can turn into anything. They hold the potential, unlike other cells in your body, to become anything you want them to become. And they can go find their home in the body and park there and do the work that you'd like them to do. You can infuse them and they will find their way into the brain. So once you know that the technology is there to edit, splice, and program a cell, and the technology currently exists to administer it to somebody and have it go park anywhere you program it to go park, proliferate, and do its function, you can have things activated in other people's brains.